First run studies explained, the lean way to build it right. You're gonna love this video because I'm gonna give you a couple of analogies that I think will like really click, and I'm going to apply this to construction. This is always a question that I'm asked. So let's talk about it right now. First run studies. Let me tell you by way of story, Dr. Marco Biniger and Dr. Janos Louis invented, through their company Tacting, a 3D printed simulation for a building that we use all the time. We absolutely love this simulation. It's better than Vallejo, it's better than other Lego games, it's better than any other simulation that I've ever been around. It's absolutely phenomenal, and they're taking it to the next level. So here's the concept. When you play this simulation, you literally have these plastic pieces, and the first time you go around, you let people do it however they want. Typically they finish that the best that it will be like 10 minutes, but typically it's like 12, 14, 15, 16, 18, 20 minutes to put this simulation together. If they keep going without the implementation of Tact and Last Planner, they'll get to like 9.5, 9, maybe 8.5, but they'll never get to the really good numbers. If you implement Tact and Last Planner, some of the fastest teams that we've seen are like 3 minutes and 55 seconds. I think there was a 3 minute 48 seconds one. It was phenomenal. They had smaller zone sizes. They were very consistent, very thorough, very good with the huddles. They had implemented both systems, Tact and Last Planner. But here's the deal. Once you start doing this simulation, you notice that people are bringing materials too fast to the simulation, and they're rushing and pushing and panicking, and they don't know where their bottlenecks are. And in this simulation, there's two trades that are really, really big bottlenecks that you have to optimize. The key here is once you implement the tact time in zones in the simulation, and then you implement a really nice optimized tact time with optimized zone sizes, and you're really going through, and typically you end up either 15 seconds or at 30-second intervals, right? And every tact time you'll stop and do a huddle, just like an afternoon foreman huddle. And it's funny, I've done this simulation probably at this point a couple hundred times, and there's this pattern that keeps emerging. The teams that even with tact start to rush, they will spiral, and they'll have to eat into a buffer, and if they're doing 12 zones, they'll finish in like 5.5, 6 minutes, 6.5. If they're doing 6 zones, they'll finish 7, 7.5, 8, maybe a little bit over 8. But if the team actually says, nope, I am not going to start anything unless I'm ready to finish. And there's a couple ways to do that. Mock-up, pre-con meeting, first run study. And so what we do is, if they're gonna go into, typically it's like, we call them column squares or a grid square, whatever you wanna call them. I call them column squares because that's what I learned at Intel when we're doing the different bays of laser scanning. But the bottom line is, you have 4 column squares, and the trade is about to go do that work, and they have to fit into either a 15-second tact time for 2 column squares or a 30-second tact time for 4 column squares, okay? Otherwise, you've blown your tact time. The teams that will say, no, let's just time it. Okay, let's try it again. Oh, okay, I know consistently I can hit this under 30 seconds. I know how to install it. I know the problems. We've vetted it out. Those are the teams that if they're doing a 6-zone strategy, they'll finish in like 6.5, 6 minutes, like way early. Or if it's a 12-zone strategy, they're finishing in like 5 minutes, 4.5, 4 minutes and like 48 seconds or something, like crazy times, crazy fast. So quality was the differentiator. So when I'm doing these simulations, I've started to say, what's the word? Quality. And we just keep talking about it. And so this concept comes from Eliyahu Goldratt and his family, his children, Ephrat and Remy, who talk constantly about full kit, the rules of flow. Full kit is one of them. And full kit means we have the information, the materials, the equipment, the human resources, and everything to finish the task before we start. Full kit. So first run studies are a key to that. So when I do these simulations with people, or when our company does it, we're like, first run study, and they're nailing it. They're going fast. They're like, oh my gosh, Jason, this is amazing. But you can't really go build something and then tear it down and build it and tear it down and build it and tear it down. So how can you do a first run study on a real construction project? Which is, you have studied how long this takes outside or before the project starts. You have observed the crew in your first zone on this project, or you have a mock-up on the project. So let me talk about those 3. And this happens a lot more than you think. You're probably like, doesn't happen. No, it actually happens a lot. Let's talk about a first run study study, the probably least effective kind, is on the project. First zone, the first wagon or task that trade is experiencing, you've helped them with a full kit, and they have all the information, the tools, the equipment, the human beings, the training, everything. They've got a full kit, even a kit of parts maybe. They're going to go install the work in that zone. You with the assistant supers and your field engineers help them monitor that first zone and help them to get it right the first time out, and they get better and better and better and better. It's not ideal, because if you have misses, you're going to, meaning on your time or quality, you're going to experience it and get better and better and better, but you've still lost that first amount of time. And you see that a lot with, I'm just going to probably use the concrete core operations on a building. For instance, you've got core walls coming up a building, you assemble the form system, the slip forms or the self-climber, and then it takes a long time. Then the first couple, you're like really struggling, then you get it, then you start going. But you've already lost that bottleneck time in the front. That's not the ideal. Better ideal, and we'll use the core forms and the core concrete operations on like a high-rise, for example, as an analogy for this one as well. Go study that crew on the previous job doing the same thing. A really great high-rise superintendent will say, oh, we're using that same core form system, whether it's just a slip form or it's actually self-climbing, and actually go look at the crews that are installing that or working with that system on a different job and observe them and do the first run study there, so we're ready here. So we're fully set up. I've seen that happen with concrete. I've seen that happen with steel. I've seen that happen with civil crews, where that crew's coming from there and coming over here, and we simply adjust our observations for the soil conditions. First run studies at these other locations. And let me tell you something. In Japan, when we visited the Toyota professionals, they said general managers at Toyota will spend 80-90% of their time with their vendors and 10% time at Toyota. Why? Because the vendors make the biggest difference for the line manufacturing at Toyota and their high mix, low volume. Because if the vendor's not performing, they're going to bottleneck the assembly plant. So the same thing, why are we not spending most of our time with our trades and prepping them before they come? The other thing that you can do is a mock-up for a first run study. And let me tell you a real story that happened to me. It actually happened on the Bioscience Research Laboratory. We had lots of steel outriggers because the exterior was framing, sheathing, air and vapor barrier, and then brick cladding with very tall windows on a highly complex, architecturally detailed exterior. Like everything was custom. There wasn't anything repeatable. So on this mock-up, which I do want to say you can now do at the home office of your exterior consultants, where they do testing and they help you with design consulting for a lot less money than on site. But we did it on site, and this contractor installed the steel not at the original duration, but at 3 times as long. And I made the mistake as a new project superintendent to be like, listen to the trade. They're like, we shouldn't have these problems on the actual building. I was like, okay, all right, fine, I trust you. And it took 3 times as long on the building. I should have known right then, and we should have had the right countermeasures. So a mock-up is a really nice first run study. So you can look at crews before they come to site, on the mock-up before they start work, or in their first zone. There might be other ways to do this. You can simulate with 3D. You can start to do some mini mock-ups. You can do a lot of different things to make sure that you have a first run study before you start work. But you have to leverage first run studies as much as you possibly can so that crews can be effective at the start, not bottleneck the site, and get quality right from the start. So at a minimum, a first in place inspection. So first run studies are amazing. I will literally put this into a blog post for you and wish you luck as you implement on your sites. On we go.